In this video, we will show how we have made autofocus 3 also process aware as we have done for MPS. So we have taken the same set of ideas of process as we've defined them in the MPS world, and in the meantime we have ported them to autofocus 3, which is a modeling tool to build software. With AF3, the modeler can build his or her software starting from requirements. So we have already here a requirements package actually that has been done. But then he or she can go on to define component architectures, safety argumentation packages, deployments. So the idea is actually to start from requirements, go through the whole process of building software and end up with code that is actually automatically generated. So if you want, it's an all-in-one IDE for modelers to build software. It's actually particularly adequate to build embedded systems. So what did we do in IDE in terms of the process? So we actually implemented the process as we also did in MPS. So the basic bricks are the same. I can show them here. You see here we have actually a process that will enforce at least partially the DO178C, which is a standard for building software for avionics. And we have a few objectives here, which mean that these are the objectives that the modeler will go through when building his or her software for avionics. So we can just take a look at one of these objectives. Let's say this one here. Every functional requirement has a non-functional requirement. So we can see here that there's a number of predefined conditions. So the conditions are predicates on the model, which actually will say if a certain condition has been fulfilled or not, if the user, the modeler, has actually built that part of the model or not. So we have one condition here that says all functional requirements should have at least one non-functional aspect defined. So this is a condition, and for this objective to be reached, this condition has to be fulfilled on the model. We can turn on others if we want. There's also the notion of required configurations or required objectives. So what this means is that there is a dependency on other objectives. So we have here all the objectives, but there's a dependency on only one aspect as defined, which is the objective that needs to be fulfilled before this one is enabled. We will now show how the process is used to guide the modeler through building his or her models. So we have two boxes here, the current objective and the upcoming objective. And the upcoming objective actually tells you what are the things that you can do right now, and you can set them. So at this point we have that the current objective, the only one we can have at this point, is the default configuration. Which actually already shows one error here. So we can just go here and see what kind of error we have. And we have an error message that says all requirement packages have at least one requirement. So this is unsatisfied, which means that we have to actually build one requirement. So let's do that. We build one requirement. And we see that you can see that the current objective is actually turned green, and we see that 100% of the constraints are satisfied. In this case, there was only one, is that there would be at least one requirement. So you can see now that at this point the IDE shows no alarms, no errors, because we have achieved this objective. But what would be the next objective if we want to continue building our model? So we can see here which are the ones that are currently available, so the ones that we should do next. So we can either complete the requirement information, define one aspect. There's an aspect of completeness also. So let's try to complete the requirement information, and as we turn this on, we see that the alarms again turn on, and then that we have actually 0% of the constraints are satisfied. So we can go here and see what is it that we need to do at this point. And we have, for example, that all requirements have a name, a rationale, an ID, an author, a description, and a source. So none of these are actually verified, because if we take a look at the requirement, we see that no information is filled in yet. So we can go on and do that. So I will just type a few some information here randomly, and as we can see here, this the constraints are being more and more satisfied. So we have here an indication that 33% of the constraints are satisfied, but we still have some errors. We can see here which ones we still have left. So the point of this guidance is that the user is always shown what kind of errors and kind of warnings are necessary at this point, which ones are pertinent, such that the user does not get overwhelmed by the information of the IDE, and at the same time that we have information about objectives, which in the future we might eventually even remove the current objective in the upcoming objective, and the process will just be something that is implicit and that will just activate, turn on or turn off the alarms as we go along.